Computers are used to proportion the materials for the desired concrete mix. Cement, sand, stone, water, and admixtures are measured according to signals from the computer. After the concrete is mixed, it is discharged into a delivery device. It's imperative that the concrete mix be delivered to the form as soon as possible. These vehicles are called tuckers, and they are used to deliver the concrete to the bed in the yard. A self-consolidating concrete is being used to cast these particular double T's. With this type of concrete, vibration is not required to consolidate the concrete. However, minor controlled vibration is used in the double T stems to help remove air from the sides of the form, reducing bug holes in the stems. There are many advantages in using this type of concrete.
We do use self-consolidating concrete for our double T's. We feel that it gives us a better finish. We feel that it's easier to place, takes less labor, less strain on the labor to place that concrete.
The QC department will make the necessary tests at this time, including a temperature check of the concrete. Since SCC is being used here, a spread test is done to check the concrete flow in lieu of a slump test. The spread is measured to assure conformance to the planned spread. The edges of the circle of concrete are also inspected to check for segregation. The appearance is translated to a visual stability index number. There is a check for air content. Cylinders are filled and will be used later for strength tests of the cured concrete. Back at the bed, the concrete placement continues. A vibrating screed is used to level the surface evenly. A bull float is used to finish the surface. An evaporation-reducing spray is also being applied to the surface to minimize the potential for plastic shrinkage cracking. The final finish will vary depending on the use of the double T. If a cast-in-place topping is necessary, the surface will be made very rough so that a good bond will be achieved. If it is a roof, the finish will be relatively smooth but not necessarily perfect. In this case, the surface is broomed as these double T's are being used in a parking structure. Different patterns can be applied depending on the needs of the project. The bed is now in its curing stage. Sometimes, particularly in cold climates, the double T may be covered with tarps. In other areas, they may be open. Accelerated curing is often done using live steam or radiant heat from heaters attached to the form itself.
Double T's for parking garages really need to be held to a high standard. When they're assembled in a garage, they make the finished surface. There are tolerances for putting these pieces together, offsets in the surfaces. All of the connections are very sensitive as well. To be executed properly, the embedments in the double T have to be placed properly. So there, again, are a lot of critical issues that you have to be concerned with to get proper performance out of that simple double T.
After 12 to 16 hours of curing, the T's are ready to be stripped. The QC department first tests the concrete to be sure it has achieved the strength required to detension the strands, typically 3,500 psi. This is a typical test being conducted. The strands are detensioned in a specific sequence established by the QC department or the plant engineer. Here, personnel are positioned at each end of the bed and at some of the intermediate bulkhead locations. On a signal, they burn the strand at each end. After all the strands are cut and block-out formwork has been removed, the T's are stripped from the form. Cables are attached to the lifting devices, and each piece is removed and transported to a detailing area for any minor cosmetic touch-ups. Also at this time, the QC department does a post-pour QC check on each piece that is brought to the detailing area.
When I first get back there, I go and check the length of the piece and verify that within, there's a tolerance of probably a quarter inch or so. Check the width, we check the vectors, we check the electrical blockouts. I do a visual for any type of discoloration in the stems underneath the piece, any type of surface cracks, bug holes, just do a complete visual.
Any defects are noted so that repairs can be done before shipping the T. After all the work is completed, the double T's are moved into the storage area where they are typically stacked using appropriate dunnage located near the ends. When the job site requires the T to be shipped, it is loaded on a trailer and transported to the job site. What you have just observed is the process for making one type of pre-stressed product. These other types are made using essentially the same process. Hollow core plank, which are used for floor and roof components in multifamily housing, schools, hotels, and many other buildings. Inverted T-beams, which can be used in any total precast concrete build system. Columns, which are cast horizontally and then rotated in the air at the job site. They are often designed as pre-stressed components. Architectural spandrels used in office buildings and parking structures can be made using the pre-stressing process. Deck slabs and box beams, which are used primarily in short span bridge construction. Standard ISTEUB girders, which are used in long span bridge construction. Standard bulb tees are also used in long span bridge construction. Pre-stressed piles that support any type of building in areas that have unfavorable soil conditions. As you can see, there are many types of pre-stressed products available. The variety of products that can be pre-stressed in a long line operation is almost unlimited and is up to the imagination of the design professional.
We really do encourage our customers and architects and engineers to get to our plants to really understand how precast concrete is made. They need an understanding of the high quality that they can get out of precast concrete as opposed to the random quality that you might get out of cast-in-place concrete.
Well, it's important that we do things as efficiently as we can and as cost effectively as we can, but also as well as we can. And it's not only my responsibility, but the responsibility of everybody here, management, labor, everybody included, to do the best job that they can to, at the end of the day, make a little bit of money, but also have a customer that's very happy and will possibly want to have some return work coming back our way.